welcome. In this presentation we are going to look at similar triangles, and in particular how to identify when two triangles are similar. By means of a definition, similar triangles have the same shape but not necessarily the same size. It is important to note that all corresponding angles are equal and all corresponding sides have the same ratio. Consider these two triangles. Now, we need to verify that all corresponding angles are the same. So you can see the angles here are 50, 60, 70, 50, 60, 70, and the corresponding sides need to be of the same ratio. So if you compare 14 with the 7, compare those two sides, think of those two sides as being corresponding. You could say that 14 divided by 2 is 7. Now, all I need for these triangles to be considered as similar, the other corresponding sides have to be divided by 2. In other words, they are of the same ratio. So 10 divided by 2 will give me 5. And 12 divided by 2 gives me 6. So yes, each one of these, if I multiply the side by 0.5 or divided by 2, I will end up confirming that my sides are corresponding. Okay, we'll just move on to the next slide, and what we're going to do is consider the different rules that we can use to identify when triangles are similar. The first rule is when I consider the angle, angle, angle. In other words, the three angles are the same in both triangles, and that can be shortened to the AAA. So you'll see here 50, 60, 70, 50, 60, 70. I don't need any side lengths. As long as those three angles are provided, then those two triangles will always be considered as being similar. The next rule. This time it is side, side, side. So if I identify my corresponding sides, such as 14 and 7, 10 and 5, 12 and 6. What I like to do is look for the longest side length over here and the longest side length over here. And I look to see what I can multiply these by now. In other words, 7 divided by 14 equals 0.5. So I consider that to be my scaling factor. Now what I do is I look for the shortest side length. So over here, the shortest one would be 10, and the shortest one over here would be 5. Now, if I multiply 10 by 0.5, do I end up with 5? Yes, I do. So I can say that those two have considered to be corresponding sides, and if I consider these two, the 12 and the 6, if I multiply those by the same ratio, 0.5, is that correct? So 12 multiplied by 1/2 is 6. 10 multiplied by 1/2 is 5, and of course 14 multiplied by 1/2 equals 7. So yes, I can say that those two triangles are similar due to the condition side, 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 or if you prefer S, S, S. Moving to the next condition. This time, side, angle, side. Or that is shortened to SAS. So they need to be basically following each other. So you'll notice that the 60 degrees has to be the included angle. So let's look at these sides again. Look at the biggest one on this side. Look at the biggest one next to my 60 degrees. That's the 7. So if those two are corresponding, what do I multiply this by? 7 over 14 equals 0.5. That is my scale factor. So if I multiply 14 by 0.5, I end up with 7. Let's look at this one here. 10 to 5. So in other words, 10 divided by 5 also equals 0.5. So I can say, yes, I have multiplied each of these sides by the same scale factor, the same ratio, which is 0.5. So the side lengths are proportional and the included angle is the same. So yes, I can say that that triangle and that triangle are indeed similar. The final condition, right angle, hypotenuse, side. So shorten to RHS. So what I do here, do they both have 90 degree angle, a right angle? Yes, they do. Now I need to compare the hypotenuse. So what's happening here? 5 for that hypotenuse, 10 for this hypotenuse. So my scale factor is effectively 10 divided by 5, which equals 2. So if I take this hypotenuse, multiply by 2, I end up with 10. Let's look at this one here. My 4, does it match with the 8? So 8 divided by 4 also equals 2. So in other words, if I take this side here, multiply it by 2, I end up with 8. So yes, I have an angle which is 90 degrees, my right angle. I have my hypotenuse, which has been multiplied by 2, and this side has also been multiplied by 2. So I can say yes, those two triangles are similar. Now let's just look at a couple of examples here. What I need to do here is try and identify my matching sides. So what I like to do, work with the biggest side length first. 84 and 14. What is that ratio? So in other words, 84 divided by, no, I'll go the other way. Sorry. 14 divided by 84 will equal a specific ratio. So I'll have a quick look at my calculator. So I'm 14 divided by 84. So 14 divided by 84 equals 1.666. So 1.66. Alright. Now let's look at the shortest side. So the shortest side over here is the 48. Shortest side over here is the 8. Now let's see whether they can be scaled in the same ratio. So what is 8 divided by 48? That is my scale factor, my ratio. So again, back to my calculator. 8 divided by 48. Again, you can see the same number. 1.66 recurring. Last side length left over. This one here. So what is 12 divided by 72? Now let's just look at that one on the calculator. 12 divided by 72. Again, 1.66. So you can see, well, have I just made a slight mistake there? I have. I really should have written zeros in front of each one of those, so I'll tidy that up right now. My mistake. So that should be a 0. That should be a 0. 0 there. So if I multiply each one of these by 0.166, you would notice that I have the same factor and the maths actually works for each one of those. So my apologies. You can see what I've done. Hopefully that makes sense to you. Moving on to the next example. Alright, this time I have an included angle and two sides. So straight away I'm thinking of the condition SAS. So let's look at the smallest over here, 9. Smallest over here, 21. What do I need to multiply the 9 by to get to 21? So my ratio, 21 divided by 9 equals, I'll be a little bit more careful with my calculator this time. So I'll just do a new page. 21 divided by 9, 2.3. Okay, so 2.3 recurring. The other side, I have 18. What do I multiply it by to get to 42? So 42 divided by 18. What do I get in this situation? So I'll put that on my calculator. 42 divided by 18. Again, 2.3 recurring, or if you prefer 2 1/3. So I take each one of those sides, multiply it by 2.3 or 2 1/3. I will get the same value, so I can say that they're being multiplied by the same ratio. Let's move to the next example. This situation here, well, I've been given two angles, 35, 75. Okay, 35 and 70. Whenever you're provided with two angles in a triangle, what you should do is look to calculate the third angle. Well, we know these angles in a triangle always add up to 180, so that angle will be 180 minus, in brackets, 35 plus 70. In other words, what is 180 minus 105? that equals 75 degrees. So I know that that angle there is 75 degrees. Likewise, this triangle over here, looking for that angle there, that will be 180 minus, in brackets, 35 plus, I have a 75. So that works out to be 110 degrees. So 180 minus 110 gives you 70 degrees. So 70 degrees there. So if I go around 35, 70, 75. 35, 70, 75. So I can say that those two triangles are similar due to the condition angle, angle, angle. Moving on to the next one. Now, this is an application of similar triangles. You are being asked to calculate this tower's height. Let's just assign the letter H for height. Could write an X, whatever. Now, does not matter. So, all I need to do is look at calculating my scale factor. In other words, identify the similar sides to my triangles. So, the H will be similar with the corresponding side will be the 1 meter. Likewise, the 8, the similar side, will be the 0.2. So what am I trying to find? I'm trying to find H. So H divided by, I'm trying to calculate my scale factor. H divided by 1 equals, back to this side, 8 divided by 0.2. 8 divided by 0.2. So I can say that H equals 8 divided by 0.2. 0.2. Well, 0.2 is 1/5, so that's the same as multiplying by 5. So it equals 40. So you can think of H as being 40 meters. So in other words, my scale factor was 40. Right, I have two more examples that I'll be going through. Right, are these triangles similar and why? Well, we're going to move on, don't want to run out of battery. I can say that that side there and that side there are vertically opposite. All right, those two sides, right, vertically opposite. They're vertically opposite. So it means the angles are the same. Now, if that's the case, I can say, well, I'm looking for an SAS. So all I need to do, look to identify my corresponding side. So on this side, highest is 14, highest over here, 49. So what is that scale factor? So 49 divided by 14. What's that equal? Quickly to my calculator. Just go to a new 49 divided by 14. There we go. 3.5. So that's 3.5. Do I have the same ratio here between those two? So 8, 28. So 28 divided by 8. Well, 3 8s are 24, and we have 4 left over, so I can say that is also 3.5. So if I take either of those sides and multiply by 3.5, I get the corresponding side. So yes, these are indeed similar, and the condition will be side, angle, side. So SAS S is the condition for that particular triangle similarity. Final one. Oops, gone too far. I have two triangles here. I'm going to look to redraw them to see whether they are indeed similar. So, first triangle. Okay, this one here. Here's my F, S, R, and what are the lengths here? 44. What is this length here? Well, that length will be 143 minus 91, which equals 52. Right, the next one. That length, the FS, will be 88 minus the 56, which equals 32. And the larger triangle, okay, right, this one will be F, E, D. Now I'm provided with all the lengths here, 121, 143, and 88. So let's just look to see whether these ratios are consistent. So I'll see if I can get just another pen color. Yeah, 52. So what I'll start with, again, I'll start with the largest, 52, the largest over this side, 143. That ratio there, 143 divided by 52. Let's have a quick look and see what that is. One, 4, 3 divided by 52. 2.75. It's not one that I could really do in my head. 2.75. Now I'll pick on the smallest. Let's identify the smallest here. 32 over here. Smallest over this side, 88. Same ratio. Let's have a look. 88 divided by 32. What does that equal? $88 divided by 32. Again, 2.75. So 2.75, and you guessed it. Let's just verify this last side length. 121, 44. So 121 divided by 44 equals 121 divided by 44, again 2.75. Excellent. So 2.75, so I can say that if I take any side on this triangle, multiply any side by 2.75, I will end up with that side. So I can say that these two triangles, right, FSR, FDE, are similar due to the condition SSS. I hope that this presentation has been of benefit to you and you have a better understanding of similar triangles. So until next time, have a good day.